Alright, in this video I'm going to be explaining the false position method, which is a bracketing root finding method. In the last video I talked about the bisection method, which is also a bracketing method, and the basic idea in the bisection method was we were just taking the interval that contained our root and cutting it in half and using that midpoint as our approximation for the root. So let me draw a little picture here to give us a little more context. If this is our function, a plot of our function, and let's say our function does something like this. And so we see that it has a root right here. This is the root. Now let's say we have some bracket. Maybe we'll pick our x lower to be this point and our x upper to be this point up here, x upper. And so what we see here is this point right here is our f at x upper, and this point right here, this is our f at x lower. Alright, now the basic idea behind the false position method is to take advantage of our knowledge of how close these points, the function at xl right here and the function at xu, how close they are to the x-axis. Now we would assume that if the function evaluated at the lower bound point, if it's closer to the x-axis than the function evaluated at the upper point, which is the case that I've drawn here, then we would assume that if the function was approximately linear, not exactly linear, there's some curvature to this function, but if it's approximately linear, we would assume that the root would be closer to this lower boundary. And that's just because this point right here, the function, is closer to the x-axis here than it is over here. So what the false position method says is, instead of doing the bisection method, which is just take this interval and cut it in half, this is the bisection method. False position method says, let's linearly interpolate between these 2 points. So I'm going to just draw a line, this is a bad line, between these 2 points, and where this line crosses the x-axis right here, let's let that be our approximation for the root. So this is the false position method. So that's the false position method's approximation for the root. Now we need to have some kind of equation for this, and I'm not going to derive it here, but in the textbook, box 5.1, there's a nice derivation. What you can actually do is you can do similar triangles. So I can take this triangle right here, and I'll do this in a different color. I can do this triangle right here, and then this triangle right here, and I can compare them in order to come up with this equation for this point right here. And the equation is our approximation for x root, that's this point right here, is equal to x upper minus f at x upper times the quantity xl minus xu all over f of xl minus f evaluated at xu. So this right here is the only difference between bisection method. In the bisection method, x root, so this is false position up here, and bisection is just the midpoint, which is x lower plus x upper divided by 2. This was the bisection method. So this is bisection right here. This is the false position. So I'm going to write a code in the next video describing bisection method, but when you write a bisection code, you've written a false position method code. The only thing you do, you only have to change one line in the code, and that is the line where you approximate the root. So you change the equation, you either use this equation for the bisection method or you use this equation for the false position method. So we'll see you in the next video where I actually write the code for the bisection method, and I'm not going to write a false position method because you only have to change one line in the code. Anyways, we'll see you in the next video.